Hello, good day viewers. In this tutorial, we want to show that the derivative of secant squared x is exactly the same with the derivative of tangent squared x. Alright, we are going to do them separately. Let me start with the first one here to the left. Let's assume this is equal to y. If y is equal to secant squared x, y can now be written as 1 divided by cosine squared x, because secant is just the reciprocal of cosine, right? So to find the derivative of this, remember, if the top is u, the bottom is v. Let me remind you, if you have y to be equal to u divided by v, for which both u and v are functions of x, then dy over dx is equal to v du, meaning you should keep the bottom constant and differentiate the top. You multiply them together, then you subtract. This time around you keep u constant and differentiate v, then you divide by the v squared, that is the bottom squared. Okay, let us apply the same thing in differentiating this. Dy over dx is equal to v du, v is cosine squared x, times du, u is the top, which is constant 1. The derivative of constant is 0, so we are multiplying by 0. Subtract. This time around the top, which is u, multiply by the derivative of the bottom. If you take this, you differentiate it. I think, should I show you every detail? You know that cosine squared x is also the same thing as cosine x raised to the power of 2. So what if you differentiate this? The moment you differentiate this 2 will drop down to multiply cosine x. But remember, chain rule, you have to multiply by the derivative of the inside. The derivative of cosine x is negative sine x. So bring the negative here, then sine x. This is now the same thing as negative 2 sine x cosine x. As simple as that. This is derivative of cosine squared x. So we have negative 2 sine x cosine x. Then divide by the bottom squared. Already it has a power of 2. Once you square that, it becomes 4. So this is cosine 4th of x. Let me delete this. You can see the whole of this will be 0, and this minus times this will become plus, right? So this is equal to 2 sine x cosine x divided by cosine 4th of x. And since we have a cosine here, it can cancel one of the cosines here to leave cosine to the 3rd of x. So finally we have 2 sine x divided by cosine to the 3rd of x. If you like, you can further break it down, but I will stop here. Then what about the other one to the right hand side, which is tangent squared x? So if y is equal to tangent squared x, remember, y can also be written as sine squared x divided by cosine squared x, because tangent is just the ratio of sine by cosine. So we are going to apply the same thing. If this is u, this is v, dy over dx will be equal to the bottom, which is cosine squared x, times the derivative of the top. If you differentiate sine squared x, it will be 2 sine x, right? Then the derivative of sine x is cos x. You see that? Then you subtract. This time around the top, which is sine squared x, multiply by the derivative of the bottom. The derivative of the bottom will be negative 2 sine x cos x. Divide by the bottom squared, it will be cosine 4th of x. Let's further simplify. You can see that this negative and this negative will become positive, and we can directly factor out 2 sine x cos x because we have it in common. Look at one here and look at the other one here. So let me bring it out. We have 2 sine x cos x. Inside, we will be left with this one from the first time, that is cosine squared x, plus the other one, which is sine squared x. Sine squared x. Already the negative sign has gone because we are multiplying this by this. then divide by cosine 4 of x. All right, remember that this is a famous identity. Sine squared x plus cosine squared x is equal to 1. And cosine x will cancel 1 cosine x here, leaving cosine third of x. So this is equal to 2 sine x divided by cosine cubed of x. Can you see? They are exactly the same. Look at it here. This and these are exactly the same. Hence, we have shown that the derivative of secant squared x is equal to the derivative of tangent squared x. Thank you for watching. Do have a nice day.